Hello, CP Finite Mathematicians, and welcome to Lesson 1.1, our first bunch of notes for this course. So as you're getting used to taking notes still, you should already have this worksheet printed out for yourselves, okay? And also, it'll always be a good idea to have your graphing calculator handy next to you here. So I have my little emulator here for you. Today's lesson, we are going to be learning how to graph the equation of a line from different forms. Hopefully most of this stuff is still review for you. But anyway, we will refresh your knowledge if it's not, which is perfectly fine. Vocabulary for today. Standard form. You might remember standard form. Those are equations in the form ax plus by is equal to c. Ax plus by is equal to c. Key things with standard form. Okay, the a value should always be positive, and it should not be a fraction. So not a fraction. Okay, we'll do a little more work with that later. Basically, we'll look at graphing standard form today. Slope-intercept form, that's the best one to graph from, really. That is in the form y is equal to mx plus b. You'll also see it as f of x for functions is mx plus b. Now, for that case, why it's known as slope-intercept form is pretty simple. It's because m is our slope, which we often think of as rise over run. B is the y-intercept, which is always of the form 0, b. Okay, so that's why pretty silly. Slope-intercept form. There's our slope, there's your y-intercept. Okay, let's look at some examples. So your questions are going to look like this. Graph each of the following. Y equals 3x plus 2. Pretty simple for these ones if you recall. First, I would say identify your slope. So our slope, or m, is 3. When it's just a 3, it really corresponds to 3 over 1, which means that we have a rise of 3 and a run of 1. Rise is up and down, run is across. The 2 is actually the first step we'll start at, and that means we have the y-intercept at 0, 2. So I'm going to plot that point on the graph, 0 to 2. Okay, from there, we reference the slope. We rise 3, so 1, 2, 3, and we run 1. So I shouldn't really plot that point for you. 3, 1. 1, 2, 3 over 1. You should do it in the opposite direction as well. And you could do it a few more times. You could do it once or twice. Once you have it plotted, then you can connect them, ideally with a ruler. I have a fancy tool here, but if you don't have that, that's perfectly fine. So 3 over 1, do the best you can to connect the points. So remember, y-intercept first, and then rise over run. Here is an example of another, slope-intercept form. Only now the big thing is, notice that the slope is negative. So the slope is going to be, I would recommend always say negative 3 over 5. Then you know it's down 3, and to the right 5. Conversely, you could also say it's up and to the left. Okay, either way is fine for that. Negative 2, that is where you'll start the graph. So this time, down 2. And the slope, if you need to write this little bit for yourself, certainly do so, is down 3, 1, 2, 3, and then over 5. 1, 2, 3, 4, 5. Again, you could also have gone up 3. 1, 2, 3, and over 5. 1, 2, 3, 4, 5 to the left. Key thing, always make sure your slopes, in this case, for negative, they should always be going down from left to right. I do want to show you on the graphing calculator also a way that you can check your work for some of these problems. So in the graphing calculator, I'm over here on the left. You can go to y equals, clear out anything that might be there, and you could simply type in -3/5 x minus 2. Okay? Make sure you get the x in there. If you hit graph, would you look at that? There's the graph for it. Even better, you can go to the table, and that's going to give you all sorts of points to graph. So you could graph 5, -5. You could graph some of the nicer points here, the non-decimals, something like, let's see, -5 and 1. And that's a great way to check your work as well. So be aware of that technique with your calculator. It has to be solved for y in order to use a graphing calculator. Our next examples are standard form examples. Okay, there's a few different ways to do this. I recommend doing the table method. So I'm going to show you the table method. And it's an X and Y intercept table. So it's going to find the X and Y intercepts. And that is simply where the graph crosses the x-axis. So X-intercept is where it crosses the x-axis. And the y-intercept is where it crosses the y-axis. To set these tables up, it's pretty straightforward. We're going to have our x and y little chart here. And we're just going to put 0 in for x and 0 in for y. So it looks like that there. Kind of like tic-tac-toe, I guess. From here, okay, what this is asking is to find the x-intercept. Actually, yes, to find the y-intercept, sorry. You're going to substitute 0 in for x in the equation. So 4 times 0 minus 3y equals 12. What's nice is 4 times 0 cancels out. We have -3y is equal to 12, and it's usually pretty easy to solve for. Y equals -4. So 1 point on this graph is 0, -4. Over 0, down 4. 1, 2, 3, 4. For the other point, well, to fill in this spot, you're substituting 0 in for y. So over here, to find the x-intercept, you substitute 0 in for y. It's backwards thinking. 4 times x minus 3 times 0 equals 12. The 3 times 0 will cancel. 4x equals 12. Divide by 4, divide by 4, and x equals 3. That means we have the point 30 to graph. 1, 2, 3. And you have 2 points. You can play connect the dots as best as you can. And I'm going to fix it a little bit here and try and get it through everything. That makes it nice as you look through the problems. But that is the table method. Okay. You also have another method. I always like the table method. It helps you out, helps you recognize the x and y intercepts. And I know I'm a little bit off here, but hopefully you get the idea. The other method, okay, is to solve for y. Now this one's all mixed up. So you might just want to decide which one do you want to put it in, y equals, or use the table method. I'll also show you you can solve for y in order to use slope-intercept. So to solve for y, I would subtract 8x from each side. So that means I have 4y minus 12 is equal to -8x. And then I would add 12 over. So 4y is equal to -8x plus 12, and divide by 4. And hopefully it comes out to be nice. Sometimes it might not, which means you might be better off using the table method. So you should be well versed in both. But that's the equation essentially we'll graph. So hopefully you get the idea. I'm going to start at 3. 1, 2, 3. And it's a negative slope. Make sure you catch that. So down 2 over 1. Down 2 over 1. And good old connecting the dots. Bada bing. All right, so you can pick which one to graph. Okay, moving forward, our two most commonly mixed up topics, horizontal and vertical lines. So please pay extra attention for these ones. Try and remember it in your brain. Here's your brain. Try and remember that vertical lines are always of the form x equals. Vertical x equals. Vertical x equals. Say it one more time. Vertical x equals. How you do these, so if it's x equals, you're focusing on the x axis, which is this axis. And you're going to plot -3. 1, 2, 3. So x equals vertical line. Vertical means up and down. Hopefully you know that. If you don't, now you do. And once you plot the -3, you're just going to go right on through it and make yourself a vertical line. It's a little funky there, but you get the idea. So x equals -3. Maybe it's x equals 4. Well, then you have 1, 2, 3, 4. Plot it through there. Right up and down. Best you can. Okay? On the other side, you have horizontal lines. Those are always y equals. So basically, if you focus on the y-axis this time, it's pretty much the same idea. This time, we're going to go 4 on the y-axis. It tells you what axis it wants. So you're like, all right, graph, I got you. And then, just right on through that point, horizontal. Horizontal, vertical. One thing to think of, so if you have a coordinate point, x comma y, some students, I've mentioned in the past, the little band, if you're a rocker, Van Halen. If you don't know them, look them up. Van could be vertical, and Halen could be horizontal. Okay? And it just goes to show that if it's x equals, it's vertical, y equals horizontal. Who knows? Maybe that'll stick with you. If not, try and think of your own. Van Halen, some other VH combo out there. Lastly is graphing on a larger scale. These are going to be great examples and great to use for application problems. Okay, when those come into play. So, I mean, in the real world, you're dealing with some bigger numbers out there, not just 1s to 10. So you might see something like a standard form equation, 1300x plus 390y. Here's where it's definitely preferred to use the table method. Okay, I also give you a blank graph, so I'll show you the key with that. So the table method is best with these. So remember, that's x and y, 0 and 0. You can also just do this in your calculator, okay? So I know I'm going to put 0 in for x. So 1300 times 0, okay, is going to cancel that out. And basically, I'm just doing 3,000 or 39,000 divided by 390. Oops, I forgot the division. Which is 100. On the other side, I'm putting 0 in for y, so that's going to cancel, and I do 39,000 divided by 1,300. So you can kind of get the trick of it once you practice more. Now, what this tells me is, again, since I have a blank graph, I need to at least go on the y-axis up 100. So I'm going to kind of see, and you can really use anything as long as it fits the equation. We have quite a few blocks here. I'm going to go by tens. So every block is 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, be sure if you're given a blank graph to show me what your scale is. On the y-axis, we have or the x-axis, sorry, we have a little more space. So I'm going to go by 5. So 5, 10, 15, 20, 25, 30, 35, 40, and so on. And then right there, those are really the only points you need to graph, and you can graph them. It would be nice if you tried to take up the most of your space, but as long as you get on the graph and you show me your scale, and you don't have to do every single number, but at least till I can get the idea as to your scale. Same idea with decimals. Don't let them scare you. So many students are afraid of decimals, but they're okay. Just take a deep breath, make the table, and see what happens, okay? 0 in for x means it's 1.30y times 2, or is equal to 260, sorry. Divide by 1.3 and see if you get a regular old number, whole number. Look at that, it's just 200. On the other end of the spectrum, it is 260 divided by 2.5, and you get 104. So a little bit different ideas here. Again, these tell you at least how far you need to go. So y-axis, I need to go to 200 again. I'm going to use tens again. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50. Good. And 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. So right there. And on the others, I just need 104. So you could do your best. I'm not going to be super particular. 10, 20, 30, 40, 50, 60, 70, 80, 90. So right there's 100. This would be 110. So I won't be overly concerned with that. Again, I'd like to see some of your work. But for the most part, get it in the ballpark, and I'll be satisfied with that. So as close as you can, if you're not given a graph already. Okay, that is graphing in a nutshell. Hopefully you remember some of that stuff. If not, hopefully it was a nice review. So great practice. Make sure you keep these. You do have to submit your notes, so you will need to submit a copy of these. And also be sure that your next task is you try out the practice problems, which are all going to be similar. So practice will make perfect. Thanks, guys, and good luck on those practice problems.